Have you ever worn a fitness tracker on your wrist? Or maybe you have seen pictures of phones that can fold in half? These are examples of flexible and wearable electronics. They are becoming more and more a part of our daily lives. We see them in smartwatches that count our steps, in special clothes that can monitor our health, and even in medical patches that stick to our skin. These amazing gadgets are designed to move with our bodies, to bend, twist, and stretch without breaking. They are made to be comfortable and convenient, fitting into our lives in a way that old, rigid electronics never could. This is the future of technology, and it's incredibly exciting. But for these flexible gadgets to work, every single part inside them must also be able to bend. Think about it. A phone that folds is no good if the screen cracks or the computer chip inside snaps. This includes one of the most important parts of any electronic device: the battery. A normal battery, like the one in your TV remote, is a hard, solid box. If you tried to bend it, it would likely break and could even be dangerous. So, for our wearable and flexible technology to truly succeed, we need a special kind of battery, one that is just as flexible as the device it powers. This presents a big challenge for scientists and engineers. How do you make a battery that can store a lot of power but is also soft and bendable? Traditional batteries are made with stiff metal casings and rigid internal components. They are designed to stay in one shape. Flexible batteries need a complete redesign from the ground up. They have to be able to handle the stress of being constantly moved and flexed. Imagine a battery woven into the fabric of your shirt or wrapped around your arm like a bracelet. It must be safe, reliable, and able to keep its power even when it's being stretched or folded. So, the next time you see a cool new wearable gadget, remember the hidden challenge inside it. The journey to create these devices is not just about making flexible screens or soft circuits. It is also about reinventing the very source of their power. Engineers are working hard to create batteries that can keep up with our moving, bending, and stretching world. These special batteries are the key that will unlock a whole new generation of technology that we can wear, fold, and take with us anywhere, changing how we interact with electronics every single day. Let's talk about the batteries that power most of our favorite gadgets today. Lithium-ion batteries. You can find them in your smartphone, your laptop, and even in electric cars. There is a very good reason why they are so popular all over the world. Lithium-ion batteries are fantastic at storing a lot of energy in a very small and lightweight package. This is called having a high energy density. It means your phone can run all day without needing a huge, heavy battery attached to it. This was a major breakthrough that allowed our electronics to become smaller and more portable than ever before. Another great thing about lithium-ion batteries is their long life. You can recharge them hundreds or even thousands of times before they start to lose their ability to hold a full charge. This is very different from older types of batteries that you had to replace after just a few uses. The ability to recharge makes them much more convenient and less wasteful for everyday devices that we use constantly. This long cycle life, combined with their high energy, made lithium-ion technology the #1 choice for engineers, designing everything from tiny headphones to powerful tools. However, lithium-ion batteries are not perfect. One of the biggest concerns is safety. The liquid inside them, called the electrolyte, is flammable. If a battery is damaged, overheats, or is not made correctly, it can catch fire or even explode. You may have heard stories about phones or laptops having to be recalled because of battery problems. This is a serious risk, especially when we think about putting these batteries into clothing or devices that are in direct contact with our skin all day long. The safety of the person using the device is the most important thing. There are also other challenges with lithium. Lithium itself is a resource that is becoming more expensive as the demand for it grows worldwide. Mining it can also be difficult and can have negative impacts on the environment and the communities near the mines. Because of these cost, safety, and environmental concerns, scientists are on a mission to find better alternatives. While lithium-ion batteries have been amazing for our current technology, the next wave of flexible and wearable electronics needs a power source that is safer, cheaper, and more sustainable for our planet. Because of the problems with lithium, scientists are exploring a whole world of other materials to make our next generation of batteries. They are looking at elements that are much more common and cheaper than lithium. One exciting option is sodium. Sodium is very similar to lithium in its chemical properties, and you can find it everywhere. It's in salt. This makes sodium-ion batteries a promising, low-cost alternative. Imagine batteries made from an ingredient that is abundant in our oceans. This could make our devices much more affordable and sustainable in the long run. Potassium is another element that is getting a lot of attention from researchers. Just like sodium, potassium is plentiful and much cheaper than lithium. It has the potential to create batteries that can charge very quickly, which would be incredibly convenient for our busy lives. Other elements being studied include calcium, magnesium, aluminum, and zinc. Each of these materials has its own unique set of advantages. For example, zinc-ion batteries often use a water-based electrolyte, which makes them much safer and less likely to catch fire than the flammable liquid used in lithium-ion batteries. The goal is to find the perfect mix of materials that can store enough energy, last a long time, and remain completely safe, even when bent or damaged. It's a bit like being a chef trying to create a new recipe. Scientists experiment with different combinations for the battery's main parts: the anode, the cathode, and the electrolyte. For example, they might pair a zinc anode with a manganese dioxide cathode in a water-based electrolyte to create a flexible battery that is both safe and effective. It's a complex puzzle with many possible solutions. This research isn't just about replacing lithium, it's about creating a diverse menu of battery options. Different applications might need different types of batteries. A medical sensor that is only used once might need a very cheap and simple battery, while a piece of smart clothing you wear every day will need one that is rechargeable and extremely durable. By exploring materials like sodium, zinc, and aluminum, we are opening the door to a future where we can choose the best, safest, and most sustainable battery for every single job. So, how do engineers actually make a battery that can bend and stretch? It's a fascinating design challenge that requires some very clever ideas. You can't just use soft materials. You also have to think about the structure of the battery itself. One popular design is inspired by an accordion or a spring. Scientists create long, thin battery components and arrange them in a wavy or serpentine pattern. When you stretch the battery, the waves simply flatten out, and when you release it, they spring back into place. This allows the battery to expand and contract without putting any strain on the active materials. Another cool approach is to use a design that looks like a paper folding art, sometimes called origami or kirigami. Engineers take a thin sheet of battery material and make precise cuts or folds in it. These cuts allow the sheet to stretch and bend in very specific ways, much like a pop-up book. This technique can create batteries that are not only flexible, but also incredibly resilient. The cutout spaces give the material room to move, preventing it from breaking when it's twisted or pulled. It's a brilliant way to build flexibility directly into the structure of the battery. To make these designs work, every part of the battery has to be flexible, including the electrodes that store the energy and the current collectors that move the electricity. For these parts, scientists are developing amazing new materials. Some are like a type of rubber or gel that can stretch to many times their original size and still conduct electricity. Imagine an electrode with the consistency of chewing gum. These soft, stretchable materials are combined with the clever structural designs to create a battery that can handle all kinds of movement without losing power or breaking apart. The future of flexible batteries is incredibly bright. Scientists and engineers are working tirelessly to make them even better. They are searching for new materials that are safer, cheaper, and more environmentally friendly. The dream is to have a power source that is as soft and comfortable as the clothes we wear, seamlessly integrated into our lives. These advancements will not only power the next generation of wearable gadgets, but could also lead to breakthroughs in medical devices and even robotics. The journey is ongoing, but with every new discovery, we get one step closer to a truly flexible, powered future.